Let's do a problem that is based on this concept. So we'll do problems that are based on the concept we have discussed. First, we will see problem based on quantization of charge. So this one we discussed yesterday. Quantization is Q is equal to N into E. And this is the charge of the electron, and mass of the electron is going to be 9.1 10 power minus 10 program. This will be given your question paper, but I would suggest you to remember it's very simple, right? So remember it. So first question. Actually, which is bigger? The question should have been -1. Which is bigger? Is it -1 coulomb of charge or charge on an electron? Which one is bigger? -A doesn't make sense. So is -1 coulomb of charge more, or the charge of the electron that is more? So in terms of magnitude, -1 is going to have more charge, right? How to get that? Yes. So how many electronic charges means how many electrons combined together is going to give you 1 coulomb of charge, right? So we know this expression, right? Q is equal to N into E. So what is the charge expected? 1 is equal to what are the number of electrons that are going to get combined to give you a charge of this 1.6 into 10 power minus 19. So what is going to be the value of N? 1 divided by 1.6 into 10 power minus 19. When you solve this, you will get 6.25 into 10 power 18 electrons. You would have seen this number, right? So the 6.25 into 10 power 18 electrons together will give you 1 coulomb of charge. Okay, please make a note of this. Is that clear? Let's proceed.
Yes, sir.
The answer is 6.25 into 10 power. So what about this question? Foam drawn through a person's hair on a dry day causes 10 power 22 electrons to leave the person's hair and stick to the foam. Calculate the charge carried by the. So how many electrons are left? So the total charge attained by the foam is 10 power 22 into charge of each electron, which is 1.6 into 10 power minus 19 coulomb. So answer will be 1.6 into 10 power 3 coulomb. This is going to be the charge that is attained. Simple problem, right? Just multiply the number, you get that. So this is based on the quantization of charge. So let's do some problems that are based on Coulomb's law. Right? See, if you observe Coulomb's law, right? There is a formula. The force between two charges, BAC stands for vacuum. Right? Force In vacuum or in air also you can take, because epsilon naught is almost the same for both. So it is 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. If at all it is some other medium, right? Instead of epsilon naught, you'll write epsilon naught into the symbol is called kappa, about which I'll discuss later. Yeah, that's what this kappa. ER or this kappa is. It's called dielectric constant. That varies from medium to medium. It's not fixed value like epsilon. So about this one, I will talk later. Right, as of now, we are not concentrating on the media with dielectric. I'll come to this point. Okay. And we know the value of 1 by 4 pi epsilon naught, which is 9 into 10 power 9 Newton meter square per coulomb. I hope this clear to this. So having this in mind, let's solve the first problem that is based on coulombs. Okay. So what are the questions stated? The electrostatic force of repulsion between two positively charged ions carrying equal charges of 3.7 into 10 power minus 9 Newton. Okay. So the electrostatic force of repulsion between two positively charged ions carrying equal charges is 3.7 into 10 power minus 9 Newton. When they are separated by distance of 5 angstrom, how many electrons are missing from each ion? So if you see, there is a question that is based on two concepts. One is they have given you the force. So force between two charges is solved by Coulomb's law, right? How many electrons? Whenever the number is spoken, it's always solved using quantization. So this is a problem based on these two concepts. So first, what are we supposed to do is find the charge on the ion. Then we will be able to find the number of electrons missing. Am I clear with that? Right. So here, if you see, the question is very clear. How many electrons are missing? So obviously, missing means what kind of an ion is it supposed to be? So it makes sense. Right? It makes sense. So I have two positively charged ions. I don't know their charges, but they told they are of equal value. So it is going to be Q and Q. Right? And the distance of separation between them is 5 angstrom. 1 angstrom is how many meter? It is 10 power minus 10 meter. Right? So what is the value of F? F is equal to 1 by 4 pi epsilon naught into Q square divided by R square. Right? It is Q square because it is Q into Q. Right? So F is how much they have given the problem. It is 3.7 into 10 power minus 9 is equal to, what is 1 by 4 pi epsilon naught? 9 into 10 power 9 into Q square, I don't know, divided by 25 into 10 power minus 20. Why 10? Because it is R square. 5 square is 25, 10 power minus 10 is 10 power minus 20. Right? So if I observe this, then I get Q square is equal to, see, 25 into 10 power minus 20 into 3.7 into 10 power minus 9, the whole divided by 9 into 10 power 9. Okay. So Q square will be equal to 25 into 3.7. I'll approximate it to 3.6. Or I'll write it as observe. I'll write it as 36. Okay. Then 36 means how much should be the number I should push it? See, 3.7, if I write it as 37, how do I write it? 37 into 10 power minus 1. Okay, I just wanted to approximate so that it's easy to solve. Okay, so if I make it as 3.7, I make it as 36. Okay, then how much should I multiply it? 10 power minus 1. Right. So what are the exponents I'm left out with? 10 power minus 20 into 10 power minus 9 into 10 power minus 1, the whole divided by 9 into 10 power 9. Am I clear with this? So how much are you getting here? minus 29 minus 1 is minus 30. So this goes to the numerator, it will become minus 33. So Q, can I write it as square root of all these values? So don't worry, you will not have this much calculation. 39, no? So how much will you get? Square root of 25 is 5, square root of 6. This is 3 into 10 power. So if you go 10 power minus 39 by 2 is what you're doing. Okay. So if I write it as 10 power minus 18 into 10 power minus 1. So that's where we'll go. Did you get a direct answer? Did you get a direct answer? No, right? It will be 10 power minus 18 divided by 10 under root. This is what you will get. 10 under root is 3.3. When you solve this, it will give you the final answer. Okay. So keeping the calculation part aside, I hope you could understand the problem. As I told you, don't worry, they'll not give you this level of calculations. Okay, but did you understand how to solve? Where? It's 10 power minus 9 only, no? They gave you. Which one? This one. There. Minus 3. Minus 90 divided by square root of. Square root of 10 is 3.3. Just see. So from this, after you calculate the value, you need to apply the formula Q is equal to N into E. So Q value already know, number of electrons into charge of each other. Okay. So I hope it is clear. So this is how the value is going to be 10.28 into 10 power minus 38. Okay. And sorry, this is the value of charge 3.2 into 10 power minus 90. We got the 10 power minus 90. No, that 5 into 6 divided by 3 into 3.3. If you solve, you get 3.2. Okay. That so 3.2 into 10 power minus 90 divided by the exact charge of an electron 1.6 into 10 power minus 90 will give us 2. So for this material, there are 2 electrons that are lost. Am I clear? Okay. So shall we try this? So there is a free ball of 8 grams which carries a positive charge. Okay, you can imagine the thermocol ball that we saw yesterday. The small balls were there. There is a small ball which is particle, right? Which consists of a charge of 5 into 10 power minus 8. Sorry. So really properly. So 5 into 10 power minus 8 coulomb. And it has a mass of 8 grams. So its weight is going to act in which direction? Obviously, downward. So the weight is going to be mg. Right? What must be the nature and magnitude of charge that should be given to the second ball, which is fixed at 5 centimeter below the former ball? So how is this one charged? Look at the question, read it carefully. Is it positively charged or negatively charged? So it is positively charged. I am giving you another ball, right? You need to place it below this in such a way that this ball is stationary, means it is hanging in the middle. Need not be equal. Need not be equal. If it should have been equal, you need to say this 5 centimeter makes no sense. You're able to understand? So, one thing I can understand is gravitational force always acts in the downward direction. So, mg is always downwards. So, if I need to balance the system, I need to apply the electrostatic force in which direction? Upward direction. So, I need the electrostatic force to be in this direction. If that should happen, means if this positive charge should experience a repulsive force, because you are keeping an object at the bottom. Anything away from it is repulsive. Means what kind of a charge is it supposed to be? What kind of a charge? It should be a thick metal. So what kind of a charge should I place it here so that it will try to push it away from itself? It should be a positive charge. Only then it can repel, no. So B should be a positive charge, but I don't know what should be the magnitude of it. Are you guys able to understand? So if this distance is taken to be 5 centimeter, yeah, that's what they've given. So 5 into 10 power minus 2 meter, right? Deal in exponential factors. So what is the equation we are going to write? Can I say that the electrostatic force should be equal to the gravitational force? So electrostatic force is given by Coulomb's law. What is the value? 1 by 4 pi epsilon naught into Q into this value 5 into 10 power minus 8 divided by 5 into 10 power minus 2 the whole square, that is 25 into 10 power minus 4. Makes sense? Is equal to mass of the object, which is 8, but it is 8 grams. So 8 into 10 power minus 3 kilogram multiplied with acceleration due to gravity. For the time being, I'll take it as 10x. Okay, because I see the multiples of 5, that's why I took it as 10. So this 5 will cancel this twice. Right? So this 1 by 4 by epsilon naught is how much? 9 into 10 power 9 into Q into 10 power minus 8 is equal to this 25 will go to the other side. 25 into 50, 50 into 8, 400. 25 into 2, 50, 50 into 8, 400 into 10 power minus 3 into 10 power minus 4. Are you able to understand at this point? So Q will be equal to 4 into 10 power minus 5 divided by 9 into 10 power 9 into 10 power minus 8. So 10 power minus 9 into 10 power minus 8 will give me a 10. So 4 divided by 90. Or can I write it as 40 into 10 power minus 6 divided by 90? 99 into 10. Why I wrote it as 40 into 10 power minus 6? Yeah, so anyways, it's the same thing actually. So I can cancel this how many times? 0.44. It keeps on going. So answer will be 0.44 into 10 power minus 6, or it is going to be 4.4 into 10 power minus 7. So I need to place a positive charge of magnitude 4.4 into 10 power minus 7 multiplied. Makes sense? Right. Let me check the answer once. Somewhat 4.36. But I hope the logic is clear. So please make a note of it.